Is it not working? Yeah, okay. So, hello everyone, my name is Vadim Bauer. I'm here to talk about Harbor as a service, or more specifically, how we run and operate Harbor as a service on different cloud providers. And you cannot start a presentation today without mentioning AI. So here is my mentioning of AI. That's me, Vadim Bauer. I'm in the IT industry since more than 20 years. This is my first computer. This is my first computer game that I played. I currently live in Zurich. Like to do some sports. And if you'd like to follow me on various social media channels like LinkedIn, Twitter, and GitHub, this is my handle. What I do, I'm the maintainer of the CNCF project Harbor. You may know about this, or you may know this project. If not, I will give a quick introduction. I'm a bit of a Container Silverback. I've been running container in production since 2013. Basically, it's Christmas 2013, right? And we do have a little service which is called AWS Container Registry, which you can find under containerregistry.com, where we offer our service as Harbor as a service to various customers. It's enterprises, it's cloud providers. So we help cloud providers adopting Harbor and offer it as a service to their customers. Not AWS, unfortunately, but it's another story. And yeah, besides working, I like to do some sport, and snowboarding is my favorite hobby. Today I would like to talk about how we operate and run Harbor on different cloud providers. So I'll give you a little introduction to Harbor. I'll show you our current stack, what we do, and how we end up there. So I'll walk you through some iterations that we have and how we ended up in this mess that we are currently in, or not mess, but yeah. I'll show you our philosophy, how we approach things, and also a bit of an outlook the things we're currently looking at, because it might be also interesting for you. Right, let's get started. Quick intro into Harbor. Harbor is a CNCF graduated open source container registry, and it allows you to manage securely your OCI artifacts, right? It has capabilities like policies, role-based access control, vulnerability scanning, signing, IDP, basically all the features that enterprises or companies require when they want to interact with a container registry in Teams. And AKS is a Harbor-based container registry service offered and operated by the project maintainers and contributors. That's us. This is how it looks like. It has a nice UI, so you can view your images like in many other container registries too. It has a nice demo, so you can make a snapshot. You can go to demo.goharbor.io. You can sign up as an admin, and you can try out everything that you want. And it gets deleted after a week, so don't use for anything serious. You can try it out yourself, right? So Harbor has a ton of features like access control, artifact distribution, and everything that companies would like to have, but it's a bit dull to talk about each and every feature. So I'm gonna look at more from the developer's perspective or from the perspective of a user that benefit from it. That's why I call it superpowers. So one of the superpowers is that it works really well for small teams like 3, 4, 5 developers up to enterprises. So it really flexible in that way. It's not very complicated, and if you add more functionality like role-based access controls and project isolation, it gets more and more complicated, right? So adapting to your requirements. It empowers developers because it has some functionalities that ease development and deployment workflows, and it's nice to work with when you have these functionalities. It makes CISOs happy. Yeah, because you can design it in a way that all your images are in one place. Like all the images from other registries that you use and distribute to are all in one place, and you can do vulnerability scanning, you can proxy images, you can control what images go out and in, and this makes CISO very happy. And it's also very attractive to ops people, because you can automate a lot of things. You can automate using REST API, you can automate using Terraform or Pulumi, you can set GitOps workflows so that your teams can request permissions, can request projects, can request replications, and all these functionalities. It has a nice garbage control system, a quota, so you can control that your registry does not overflow, and so on. So this is a bit important for later. So Harbor is not a simple system, right? So it has a few moving parts. It is based on Docker distribution. Docker distribution is more used as a framework. It is hidden there with the clamshell. It has a component for the GC controller, a job service that has a core component with the API and has a UI. It has also some components to third parties like vulnerability scanners. It has a dependency to a key value store. In this case, it's Redis. It has also dependency to SQL database, and it has also dependency to persistent volumes or persistent blob storage. So it might be S3, it might be a file storage. So you need a place to store your images somewhere, right? So it's three dependencies. And this is a bit what Harbor, how it looks like. Now we're starting from the end. So how is our current stack, or how does our stack currently look like, right? So this is our tech stack. So I'm trying to walk you through. We are deploying Harbor on multiple cloud providers, and this is represented with, can you see? Yeah, you can see, right? No? Oh, okay. So this is represented with this, layers. So we have support from multiple cloud providers, and on each cloud providers we can of course have different instances, or we deployed multiple instances. This might be AWS in the region in US East, US West, Europe, and whatever, or it can be just one instance. And then per cluster we have multiple tenants, right? So each tenant or each customer gets their own instance of Harbor. Right. And this contains all the shebang that I showed you before with all these components. And we have external dependencies, so we are not having, we don't have a stateful Kubernetes cluster. We try to have it stateless, at least most of the time. So we have some state here. But in our workloads, we have an external state that we store Postgres. So in the case of AWS, we're using RDS, and other cases we use the equivalent offering from the cloud provider. And the worst case we do it ourselves, but we try to use the cloud provider's offering. And then the second dependency that we have is an S3 bucket. This is what we choose to store the blobs and the images, and this is mostly also provided by the cloud provider, right? And then we have also, depending on situations, we use also some KMS functionalities. For example, on AWS we use it. Otherwise, we don't use it. We use other solutions like SOPs. And then we have another stack, which is our monitoring stack, or our daily work stack, I would say, because it has the monitoring stuff in it, like Prometheus, Loki. It has also our management applications there, like the ordering service, the tenant management service. It has also some other functionalities, but this is not relevant. And then we have, of course, a bunch of SaaS applications that we use. I just put them here. It's just a few. We have more, but this, in my opinion, are the ones that are relevant here for this talk. It's like the Superbase. It's a backend as a service offering. We don't really need it, but it's part of our stack now. We have you can order the registry over the AWS Marketplace. We have Chargebee for subscription management. We have GitLab for the pipelines and the codes. And we have Grafana Cloud, where we have the monitoring and our dashboards. And then we have HubSpot as a CRM for the contacts and the support tickets. So over time, we developed iterated our stack, so we have a kind of a multi-tenancy offering on top of Harbor, and we still offer the isolated version. So this means like every customer gets an instance. However, the database is shared. They have a shared database, but on each database instance there is a dedicated database, and there is also a per tenant S3 bucket. We have also implemented more lightweight solution, which is one instance, and then there's a multiple isolated projects. This is mostly used with cloud providers that are offering Harbor to their customers, and we are currently working and testing a fully multi-tenant solution where we have just a single instance of our application and the registry, but we have multiple buckets. So we have a bucket-based isolation, and we have also a database isolation. So this is what we're currently working on. So how did we end up here? So this is a bit important for the further discussion. So when you order an instance from for example, our website or the AWS marketplace, your request will come to the ordering service, and the ordering service will interact with the subscription management system. It will store some data. It then triggers the pipeline, and the pipeline will then do the deployment. And the interesting part here is that first that we trigger a pipeline that does the deployment. Why we're doing this? And the second part is that the tenant data is stored in Git. So we encrypt and store the tenant data in Git. This is also a bit specific, and the main reason why we're doing it and not in a database, completely in an application, is basically we have the option that we can do customization on tenant basis. So if the tenant requires some functionality, for example, IP blocking or some other functionality that Kubernetes or the application provides, we can configure it on a tenant basis, right? So this is a quite powerful functionality, and then we check it in from our developer machine and then run the pipeline, and it's deployed. So this is a bit of why we do this approach a bit. So how did we end up in this situation, right? So we're doing this registry thingy since 2016, 17. Right? So we started really early, but in the first days it was just more of a side business because we did consulting, and it was like kind of more of a side business. The whole containerization was not that popular yet, and so there was not demand. And now since 2020, we do it more seriously and divide all our time there. So I'll break it down in 4 parts, like the cloud provisioning, how we do the cloud provisioning, how we do the application runtime orchestration, how we do the application deployment, and how we do the observability. Right. So our current state in cloud provisioning is that we have 5 different cloud providers. I think there are 3 or 4 active providers. I'm not really sure. AWS is one of them. Exascale here in Switzerland. There is also Scaleway, and there are 2 other cloud providers that we have, but we don't have customers on them at the moment. They're also in Europe. And so we have 2 new providers in progress. It is Azure, because customers requested it, and there's also one in the US, DigitalOcean, because it's cheaper than AWS. Right, so the current state is we are using Pulumi, so the Pulumi to defeat the dragons, and the dragons are here AWS and Azure, because this setup is quite complicated of Kubernetes and all this stuff on AWS and Azure, and that's why we use Pulumi. For other cloud providers, that's the more simpler ones like Exascale or Scaleway or another. They are so simple that we use just point and click. Every time you need a cluster, you go in the console, select the Kubernetes cluster, and then you go. It takes maybe 5 minutes, maybe 10 minutes, So there is no point to automate it, because automating it takes maybe 1 day. Maintaining the automation maybe like 2-3 days per year, right? And so the time that you will waste on this automation and maintenance of the script is 10 times more than just spending 5 minutes and creating a new cluster. And we're not creating new cluster every day, so it's maybe 3-4 times a year. We also do Bash. Sometimes it's still helpful, and we use the Boto SDK, for example, for S3 buckets. This is surprisingly working well across multiple cloud providers. It's not only on AWS. It basically works on all cloud providers that offer S3 buckets. So that's why we're using it to provision buckets for tenants on the fly. So how we end up with Pulumi, instead of Terraform, which is the most popular one. The main reason was because the flexibility of Pulumi. You may not know it, but Pulumi is using the same Terraform providers underneath than Terraform, right? So they're using Terraform providers underneath, but they offer a different syntax to configure the infrastructure. They're using programming languages like Golang, Python, and JavaScript. So the outcome is the same, but it's just the syntax is different. But the different syntax allows us to easily customize things, because we have like different setups for different customers, right? And we don't want to do this with Terraform. It's more complicated to do with Terraform. We do it with Pulumi, because then we can, in code, we can define out this is functionalities for this customer, and then we can use the basic, programming language capabilities that are there. We use to make our life easier, and this is not very easy to do with Terraform. And the good thing is the declarative nature of Terraform is still preserved, even though we're using programming language, which is by definition is not declarative. The outcome is declarative, so that's why the outcome of the whole system is declarative, which is nice. And how did we get there? Like, first we of course started with Bash scripts. We did even as Ansible. This was before Kubernetes time. We did Vagrant Packer. We did, of course, point and click. And we still do it today. We did Terraform. This is, we did it quite a lot actually. We did even CDK. If you don't know CDK, it's in AWS function, in AWS tool similar to Pulumi, where you can use code programming languages to describe your infrastructure, but it does not use the Terraform modules and codes underneath. So it uses it uses CloudFormation, right? So it uses CloudFormation underneath, which is very fun to debug. It was a joke. And so that's why we ended up with using Pulumi. We use SDK and Bash at the moment, right? So how about the container orchestration? So why, what is the current state, right? So we use Kubernetes. So we take the CSP offerings. So CSP is cloud service provider, like AWS. So we use their offering, like EKS, AKS, or from other cloud providers, however, whatever their name is called. We mostly use vanilla Kubernetes. We don't have any specific requirements there. We of course deploy the provider-specific operators, like the one for the NLB, the one for the IAM, for EKS, for example, or EBS volumes. And then we try to reduce complexity, and we try to use the technology that is proven and is not fancy. We're currently looking at other options like Talos, Linux, and Kairos, but we try to really minimize and use our Kubernetes as more as a framework, right? Rather than like an application runtime, but more as a framework. So what are we using? So we're using like Kubernetes for the applications themselves. They're mostly stateless, right? And we're using Cert Manager. We don't use the cloud providers offering because they're not consistent across different cloud providers. Every cloud provider has something similar, but you have to configure it differently. So that's why we stick with something that's familiar to us and works across all providers. Cert Manager. We used Ingress Nginx. We don't use an ALB. So here as well, we know how it works. We know how it operates. We know how it behaves with our application. So there is no surprises. We just stick with that. The same goes with Prometheus and Grafana. It's common technology in the Kubernetes space to use Prometheus and Grafana, so we use that. For secrets management, we stick also with a simple solution. We're using SOPs instead of Vault or other application or services, which is easy to operate, easy to use, and doesn't have dependencies. And then, of course, we use Helm for application deployment where we need to. Our evolution was, we started with 2016, around that time, and we did, one VM per tenant, so a small VM, one tenant. We used Docker Compose to deploy our application, and then we moved on to have a bigger VMs and then have multiple tenants per VM, and more Compose files. We tried Swarm for a while, tried to make it work. It didn't work. It failed basically. It was a lot of effort to try to make it work, but it didn't. We tried also with Kubernetes first at 2019 or 18, I'm not sure. It failed as well because it wasn't mature enough, or we weren't mature enough for that. I don't know, but it failed at that time. And then we, started using CSP managed Kubernetes offerings, and this is something where things took off, and then we migrated everything to Kubernetes, right? And we are basically using Kubernetes as a platform for building our application. So we are not treating as a kind of a more of a runtime environment. Of course, it is a runtime environment, but we also treat it more like as a platform where we can build things upon. We're using the API. We try to use the API. We listen to events, and we kind of interact more with the Kubernetes to know how to deploy applications. So why Kubernetes? So why? I mean, there are more lightweight solutions, right? If we are talking about operating SaaS and distributing SaaS, maybe even serverless or something like this would be more suitable. But the main reason is, our end users use Kubernetes, right? So our end users who use our container registries use Kubernetes mostly, and it's also good if we know how to do it, because then we can develop the product in this direction, and we know how people are using the product, right? Our customers are using Kubernetes as well, right? So for their own workloads, and it gives them a really nice abstraction of different cloud providers, right? So we have a really nice abstraction of our cloud providers. We use the same basic tools. We have a benefit from a rich ecosystem, right? Well, software tools, workflow, even integrations, like they're all, Kubernetes is a masterpiece in that regard, like the CNCF here. There are so many tools, which is on the other hand really difficult, but it's very powerful if you're, can find your way around that. So how are we doing now the application deployment? I need to take a look on the time. How are we doing the application deployment? And it's super easy, right? So it's this little button there. So this is like the evolution, how we got there. But the current state is we are using CDK. We're using CDK 8S. I'm not sure. Did anyone heard about CDK 8S or try it out? No hands? One hand? All right. You should definitely try it out. It is inspired by CDK, right? It uses the same libraries underneath, but it's also a programming way to define your manifest, right? So the good thing is you don't have to work with the YAML files, which is a really nice benefit, or you have to work less with the YAML files. You have to still look at the YAML files and work with the YAML files, but it's much, much less than before. And it's a really powerful functionality because you have the same declarative nature, but with the programming language. So you write proper code, you can use your proper abstractions, and you get really nice manifests, and they're flexible, and you don't have to deal with Helm templating hell, right? And we still use Helm for third parties nowadays. In combination with CDK 8S, we can configure the value files with CDK, which is also very powerful and very helpful, just to instead of just writing YAML files. And we use GitLab CI/CD to deploy our applications. We're not there yet with GitOps. We're investigating that, so we're a bit of cautious about that. CDK 8, because we know programming languages, we know how to program software. It is super flexible, so we can do customizations there. We can also use it for customization to our customers. The absolute fantastic thing about a lot of those tools in this space is that they always produce manifest at the end, and if you have a manifest, you can always compare what you think there should be, right? So it's very powerful, and so tools that don't produce manifests are basically useless in the Kubernetes space. And there is no YAML templating hell, which is also very nice. If you know Helm templating and then Golang templating, this is very a nice relief, right? And so how did we get there, right? We started with Docker Compose. I mean, we still do use Docker Compose for local development. We did Terraform. We did Terraform for writing the manifests. Didn't work because there is no separation from the infrastructure. We tried to use Helm in combination with Helm file. If you're using Helm, you should definitely take a look at Helm files. We're still using Helm file from time to time in some certain use cases, but the Helm file makes working with Helm much easier. We used Customize, was not as good as CDK that we ended up with now. So the last part is the part about observability. And as I said, we are using Grafana Cloud for our observability, for monitoring logs. And we are using, in the past, we deployed Prometheus and Loki per cluster, and then aggregated, or not aggregated, used Grafana to look into different clusters, which was working fine, it was okay. But it was a bit more of maintenance, and we had to have stateful clusters, right? So stateful, we needed to have persistent volumes. And since a few months, we switched to Grafana Agent. And Grafana Agent is a tool that has basically the same APIs that Prometheus and Loki, and uses the same CRDs that as Prometheus and Loki, right? If you're familiar with Kubernetes and monitoring, you use this CRDs. And so it's compatible to those CRDs and APIs, but what it does, instead of implementing Prometheus and Loki, it just takes the data and ships it to a proper Prometheus and Loki stack. And this is what we're doing. We're using a Grafana Agent, it's called. This is nice. This is the icon. And we ship the data to our Prometheus cluster and Loki cluster. And as I said, we are using Grafana Cloud, which is a SaaS offering from Grafana, where you get Prometheus and Loki out of the box. We're not using that, mainly of cost reasons. It can get quite expensive if you have like that many customers, that many metrics, that many data. So it is quite expensive, right? So if you like reaching that scale, and because we know how to operate Prometheus and Loki, and it's not very complicated, we do it ourselves. But we still use Grafana Cloud because it has some enterprise features that you get with the subscription, like user management and things like this. And that's definitely worth the price. And that's why we're using a combination of SaaS and on-prem. Yeah. So this is how we do the operations, and we did over time we did different tryouts. We also tried to use AWS for logs, but only in the context of AWS. But it was a bit cumbersome to just have a specific solution just for AWS. So we decided to just dump everything and just use Prometheus for everything. And so far it works really great. So as you might already guessed a bit, like our philosophy is not to do things as complicated or try to be complicated. So one motto is not don't be a smartass. This means if you're very smart, people tend to show that they're very smart, and this results in very complex solutions or complicated solutions. And so that's why it's keep it simple, and we try to use proven technology, so like things that exist, that are well documented, that are known to work. So we just follow the majority in the CNCF space, at least, right? We invest in simplifying. So there's a nice quote. So it's better to invest 10 days and delete 1,000 lines of code than to write 10,000 lines of code in one day. And the other thing has to do something with vendor locking, right? So invest in usable technology and knowledge. And I think this is part of vendor lock-in that is not talked about. So because when we talk about vendor lock-in, we are kind of talking about using the services of one cloud provider and committing to these cloud providers. But there is much more to that. There is also knowledge. Like you invest knowledge in building up knowledge to understand something, right? And this is also a big part of the vendor lock-in that not get the attention that I think that it should have. There's a really nice talk about modern cloud apps by Gregor Hope that he did in Bern and Cloud Native Day. You should really take a look at this. So this is our philosophy. And do we have time? Yeah, we have a bit of time. There are a few things we're currently looking at. One important thing is that in the trend in the edge, like Kubernetes at edge, containers at edge. So we're looking into the space how we can also support this use case with our registry and also with our SaaS offering. So how can we offer a SaaS that is running at edge, or our registry running at edge, and how we can support those use cases. So there are twofold areas here that we're looking at. One from the business perspective, and then the one from the user perspective, right? Then the full multi-tenancy is an important part to reduce to raise the efficiency of our clusters and reducing complexity. Then scaling Kubernetes globally is an interesting topic that we're looking into. Like how can we have a global Kubernetes cluster? Like cluster interconnect, global distributed cluster like Cilium are interesting areas where we currently look at and see if they evolve in a way and matured enough so that we can use them. Another topic is serverless, and here specifically we're looking at Knative, which is a very powerful functionality of how we can run serverless applications on Kubernetes. We're trying out, see how this is working, but we didn't yet deploy it in production. We currently use OpenFaaS. And then the other big topic is GitOps, right? And GitOps is Flux versus Argo CD. So who is Argo fan? Who is Flux fan? Argo? Flux? Yeah. I'm also currently tending more into Flux, so we're currently looking at the different options to see what fits best our use case. And that's it from my side. I have some time from Q&A. If you have questions.